Now that we've looked at different types of graphs, we're going to be able to draw some qualitative graphs as well. So we're going to take the next step and create our own graphs. So let's read the description of the situation and view a sketch of the corresponding graph. We're going to answer some questions about the qualitative graph. And then we're going to summarize what the graph shows in the context of the situation. It says, think about ways to solve the problem on page 94. Angela and Lori are hiking a mountain. The beginning of the trail is not too steep, and they start off at a quick pace. They stop and rest for several minutes, then climb a steeper part of the trail at a slower pace, until they reach the highest point on the trail. They rest again before climbing down at a constant rate, faster than they climb the mountain. Sketch a graph to show the distance compared to time. So first, let's analyze this problem and let's take it apart like what we've been doing. What is this problem about? We know that it's Angela and Lori hiking on a mountain. Sometimes we see these big paragraphs and it gets overwhelming because there's so much information and it looks like a lot of words. But we always go back to what we know and how we break it down. So our next question is, what are we trying to find out of all of this? So I'm going to be looking for maybe a question, something with a question mark, or I'm looking for some verbs. This problem is going to tell me to do something. This problem is telling me to sketch. Sketch what? A graph to show the distance compared to time. So we're just drawing a graph of time and distance. We know that time is going to be our x-axis from our experiences with all the other graphs that we've seen in every other problem. Time is always on our x-axis, so we know that much. Let's look at our next problem, or let's look at our next step. Now we're going to try and find out what is important information in this reading, and there's a lot of information. And that the beginning of the trail isn't too steep, so they start out pretty quickly. We know that they stop and rest for several minutes. Then they started climbing a steeper part of the trail at a slower pace until they reached the highest point. So this is going to be probably the midway part of my graph because I can't get any higher. Rest again. That mountain view is very beautiful. We know that they're climbing down at a constant rate. Okay, so it's going to be a straight line faster than they climb the mountain. Okay, because there's a lot of that momentum, they're going to increase the speed. Gravity pulls us down even more, so they're going to go faster than when they actually climb the mountain anywhere at the beginning of the trail. So we know that this is going to be they might be a very, very steep line. So now that we know the whole story and we know that we started at a point and then we're looking at height, we're going to end up at the top of a mountain, which the height is going to increase, and then we're climbing back down and we end up at the bottom of the mountain, so that line is going to decrease. Let's take a look at our line and break our story into parts and analyze each part. Okay? At the beginning, we started the trail at a quick pace, section A. Then the slope of the segment is that slope of the segment is pretty steep. Okay, we're doing a mountain climb. Then before getting any steeper, we rest. This is our horizontal segment. And then here, that trail is steeper, so the pace is a lot slower. Then in section, what we know is that the pace is a lot slower than section A. So if we're going slower, my distance from the starting point is going to be a lot lower. And then that segment isn't as steep as part A because they started out pretty quick. Okay, so the faster they go, they're decreasing their time to get up here. Okay, but now they're going slower, so it's going to be extended and it's going to be a lot less steep. And then they're going to rest again at D. So this is a horizontal segment. Okay, it's constant pace. They rest. They're not doing anything for an amount of time. And then they climb down at the quickest pace, because when we go downhill, we go a lot faster. This is a steep downward segment, and then they end up at their starting point once again. Okay, please note, when we're climbing, we always end up back down here if we're getting to any starting point. Okay, we always, if we're talking and we're reading about a problem verbally, and we say we start somewhere and then we end up at the starting point, we're always going to end up back on this x-axis. Y is a slower pace represented by a less steep line, and a faster pace represented by a steeper line. Okay, notice how the slope of this line is more than the slope of this line. It's because our y-axis shows the distance and the x-axis shows the time. So a slower pace means there's less distance traveled per unit of time. A faster pace means that there's more distance covered during a unit of time. Now we're going to sketch a graph of a situation similar to the one on the previous page. Let's read the problem. It says Mrs. Elijah does errands on her lunch break. She starts walking quickly, but then has to slow down as the sidewalk gets crowded. She stops at a store and picks up a few items. She walks quickly back to the office since there's no longer a crowd. Okay, so just understanding my story. Okay, I know that Mrs. Elijah starts out at her office. She follows a certain route, then turns around and takes the same route back to the starting point. So that means that my graph is going to start looking like it starts at the x-axis, and since she's going back to that starting point, I'm going to end at the x-axis as well. What is this problem about? It's about Mrs. Elijah doing errands on her lunch break. What's this problem asking? It's asking us to describe the first segment of the graph and then what the slope of the segment should look like. It's asking us what should the slope of the graph for the second segment look like. And then it's asking us to describe the third part of the story and tell what the graph looks like for this section. And then it also is asking us to describe the graph, what the graph should look like for that last segment. We know that she starts off quickly, then we know she slows down because the sidewalk gets crowded, then we know she stops, and then she walks quickly back to her office. These are things we know. The first segment in our graph is going to look very, very steep because she starts off very quickly. And we know she has to slow down. So the slope is going to be less steep than the first section. Then we know she stops. So when Mrs. Elijah stops at a store, her distance from the office does not change. That segment on the graph is going to be horizontal. Last, she walks quickly back to the office. So that means that she walks quickly back to work. The segment has about the same slope as part A, but in a downward direction since she's heading back to the office. Every time we make a loop back to somewhere that we started, that means that we're going to end up at the x-axis. We're going to end up at 0 on x. Let's use what we learned about sketching qualitative graphs to solve these problems, number 12 and number 13 on page 95 in your student textbook. We're going to show our work on a separate sheet of paper, or you can do it right next to your book in that blank area. Okay, number 12 says, use the answers to problems 8 to 11 to sketch a graph for Mrs. Elijah's distance from the office over time. Draw your graph in the space to the right. First thing I'm going to do is I'm going to draw my y-axis and my x-axis. My y, x. Now I'm going to label them. We learned from this lesson that our x-axis is most likely always going to be time. We also know from the problem that Mrs. Elijah is going from the distance from her office. Mrs. Elijah walks quickly, so that first section of our slope is going to be steep. Then she has to slow down, okay? But my distance from the office is still going further away, but she has to slow down, so it's a lot less steep because there's a lot of people on that sidewalk. Then we plateau. The slope is less steep than that first section, but then she plateaus because she stops at a store, so her distance from the office doesn't change. She's in this store for a certain amount of time. So the line's going to continue to move from left to right, but notice how the distance doesn't change because she's still at that store. She's still at that office. She's shopping right now, and she's not going anywhere but in that store. Then she walks quickly back to work. So that means that the segment is going to be steeper. It's going to be the same slope as A, but in a downward direction since she's heading back to the office and there's nowhere to go along the way. Next problem says Pablo starts walking to the park. Halfway to the park, he starts jogging. When he gets to the park, he stops to rest. Finally, Pablo walks home at the same pace as the first part of his trip. Sketch a graph that shows Pablo's distance from home compared to time. Draw your graph on a separate sheet of paper, okay? You can draw it right next to there. Your graph is going to start off with where Pablo walks to, and that's the park, okay? So let's answer those questions first. What is this problem about? Pablo's going to the park. This is problem looking for. We have to sketch a graph that shows Pablo's distance from home compared to time. Notice how he walks home. So my graph is going to start off at the bottom of my y. Okay, so my y is 0, and then I'm going to increase throughout time on my x-axis, but I'm always going to end up with my y as 0 because I'm starting the same place I'm ending the same place that I started. So we know we're going to have 4 different sections. We know he starts walking to the park, then he starts jogging. So I'm going to have a little bit of a steep line there because it's going to increase that distance over a short amount of time. Then he stops, so I know I'm going to flatline, and then he walks home at the same pace as the first part of his trip. Okay, so Pablo's trip to work is halfway to the park. The slope gets a little bit steeper, and then at the park, the slope is flat. And then after the park, the slope is going to be less steep all the way back to the horizontal axis. So visually, our slope and our line, our function, actually looks like the one from Mrs. Elijah's. We start off walking to the park. Halfway to the park, we start jogging. So this might actually be steeper. So let's draw it. First, I'm going to draw my x-axis. Then I'm drawing my y-axis, and I'm labeling them so that I don't forget which is which. Once again, I'm going to label my x-axis time because it's over a certain amount of time that Pablo starts walking to the park. And then we know that our y-axis is Pablo's distance from home. Pablo goes to the park. There he starts jogging, so my slope is going to get steeper. While he's at the park, the slope is flat. It is plateaued because he's resting. So he stays there, but over time, he's not really moving. He's just chilling there. After the park, the slope is less steep. Okay, notice how we meet a little more over time because he's not running anymore. He's just walking. So all the way back, and then I hit my x-axis again on my x-axis here for my time. Okay, so he ends up back on my x-axis. Now that we're finished, go ahead and finish up your Nearpod and then complete the practice pages in your book for this week.